Hello my dear students. In this video I will discuss the types of function. So let us start with the first one. The first type of function is the constant function. Let us see what is a constant function. A function f from x into y is a constant function if the same elements y in y is assigned to every x in x. That is, the function f is a constant if all the elements in x, that is in the domain, are assigned to same element in the codomain. That type of function is called a constant function. Examples: if we have these three functions f, g, and h, and they are defined by the diagrams below. Let us see the diagrams. Look at the function f, look at its diagram. The function g, look at its diagram. And the function h, look at its diagram. So starting with the first function f, you can see all the elements in the domain, that is set x. They are assigned to only one element, meaning same element in the codomain, which is 2. You can see the image of all those elements in the domain is 2. So this f is a constant function because all the elements in x are assigned to same element in y. Let us see function g also. Function g, look at the elements in the domain, that is set x. All those elements in the domain are assigned to same element in the codomain, which is 10. So the images of all those elements is the same, and it is 10. So this is also a constant function. But looking at the function h, look at the elements in the domain, that is a, b, and d. And the two elements a and b have same image, which is 10. But the element d in the domain has another different image, which is 15. So this h, because all the elements don't have same image, then h is not a constant function. So we can now write f constant function, g is a constant function, but h is not a constant function. Thus, a function f from x to y is a constant function if the range of f consists only one element. We can see in these two functions f and g, because they are constant function, the range there, remember, range is a subset of the codomain. It comprises those elements in the set, those elements that have pre-images. This is what gives you range in our previous lesson. So you can see that in f, in the function f, the range of f will now be a set containing element 2 only. Similarly in g, the function g, its range will now consist only elements 10. So if a function is a constant function, the range of that function will consist only one element. Example number 1 of a constant function, it says let f be a function from real number to real number and is defined by the formula f of x equals to 5. The question asked here is to state whether or not the function f is a constant function. Solution to this problem: copying the formula for the function f of x equals to 5. This means the function f always gives a constant number 5, whatever value of x. So since for every x in R, meaning x in the domain, the f of x is always constant, it gives answer 5. Then we can conclude that this function f is a constant function. The second type of function is called one-to-one function. Let us see what is one-to-one function. Suppose we let f to be a function from x into y, The function f is called one-to-one if different elements y in y, meaning different element in the codomain have different pre-images x in x. If different elements in the codomain have different pre-images in the domain, then that function is one-to-one function. Let us see examples of one-to-one function. Example: if f, g, and h are functions defined by the diagrams below. Look at the function f, it is diagram. Look at the function g, it is diagram. And look at the diagram of the function h. So starting with the function f, looking at the assignation of the elements from the domain into the codomain, you can see that all the elements there in the codomain, that is the element 0, 2, 6, 12, and 20. You can see all those elements, if you trace them back, they have different pre-images. No single element in the codomain that has two pre-images. Each and every element in the codomain has only one and one pre-image. Then f is a one-to-one function. Let us see function g. Look at the elements in our codomain, or rather the elements in our range. Each and every element you pick in the range, you can see that it is pre-image is only one pre-image it has. You can see -1, it is pre-image is -2. The 0 in the codomain or in the range, it is pre-image is -1, and so on. So if this thing happen, all the elements in the range have different pre-images in the domain, then that function is one-to-one. But let us see function h. The function h, looking at 0 in the range, or rather 0 in the codomain, you can see it is pre-image a, b, and d. Then that function h is not one-to-one function. For it to be one-to-one functions, all the elements in your range must have, or different elements in the range must have different pre-images. Thus, if f is a function from x into y, and the function f is one-to-one, it is one-to-one if two different elements x in x, that is in the domain, have the same image. If there is no two different elements with the same image, then that function is one-to-one function. Example of one-to-one function. The question says let f be a function from set of real number into set of real number, and let g be another function also from set of real numbers into set of real numbers, and the two functions are defined by the formula, and the function f is defined by the formula f of x equals to x squared, and the function g of x, the function g is defined by the formula g of x equals to x raised to the power of 3. The question asked here is which of this function is one-to-one. Solution to this problem: we start with the first function, the function f. We copy its formula f of x equals to x squared. What we now do to check whether the function f is one-to-one or not, we try to pick different elements in the domain and see whether they have same image. If they have same image, then it's not one-to-one. But after testing or after checking different elements in the domain and their images are also different, then the function is one-to-one. So let me test f of 3, meaning the image of -3. The image of -3 is in the domain. Let me find its image. In the image of -3, I will now substitute -3 there in the given function. Instead x, I will now substitute -3 there. So f of -3 would now be equals to minus 3 square, and minus 3 square is simply equals to 9. So f of minus 3 equals to 9. That is, the image of minus 3 is 9. Let me check the image of 3. The image of 3, that is f of 3. I will now replace the x by 3. So there I will have f of 3 to be equals to 3 square, and 3 square equals to 9. You can see that these images of two different elements, minus 3 and 3, which are in the domain, their images is the same, which is 9. Therefore, this function is not one-to-one function, because I can see that two elements in the domain, minus 3 and 3, have same image. So the function f is not one-to-one function. Let me check function g whether it is or not. Copying the formula for the function g of x equals to x raised to the power of 3. I will also do the same. I will test some different elements in the domain and see whether their images is the same. So let me check also the image of minus 3. That is g of minus 3. I will now replace the x by minus 3 in the given formula for the function g. So there I will have minus 3 raised to the power of 3, and minus 3 raised to the power of 3 simply give answer minus 27. Minus 27 is the image of minus 3. Let me pick up 3 also. The image of 3 under the function g. I will now have g3 to be equals to 3 raised to the power of 3, and 3 raised to the power of 3 equals to 27. The image of 3 under the function g is 27. So you can see that g of minus 3 is not the same as g of 3. Therefore, different elements in the domain have different images. Then the function g is one-to-one function. You can test as many values as possible. The third type of function is called OnetoOne function. Let us see what is OnetoOne function. Let f be a function from x into y. The function f is called OnetoOne if every element y in y, meaning y in the codomain, appears as the image of at least one element x in x. This definition simply tells us that all the elements in the codomain have pre-images in the domain. If that didn't happen, then the function is OnetoOne function. Examples of OnetoOne function, let us see the functions f, g, and h are functions defined by the diagrams below. Look at the diagram for the function f, look at the diagram for the function g, and look at the diagram for the function h. Let's start with the function f and see whether it is OnetoOne or not. For it to be OnetoOne, all the elements in the codomain must have pre-images in the domain. So let us see the function f. Our codomain is the set y. You can see all the elements there, 2, 6, and 12. The elements in the codomain, if we trace them back, you see that they have pre-images, either 1 or 2 pre-images. Then the function f is OnetoOne function because all the elements in the codomain have pre-images. Let us move to function g. In the function g, let us see also our codomain. The codomain is the set y. Let us see the elements there in the codomain. All the elements there, minus 1, 0, 2, and 3. If you trace back, they have pre-images. Therefore, the function g is also an OnetoOne function because all the elements in the codomain have pre-images. But the function h, looking at its codomain, you can see an element 2 in the codomain and an element 4 in the codomain. They don't have pre-images in the domain. With that, we can now conclude that the function h is not OnetoOne function. For it to be onto function, all the elements in the codomain must have pre-images. Thus, suppose f is a function from x into y, and that function is an onto function. It is onto function if the range of the function f is equals to the codomain of the function f. If this not happen, then the function is onto function. Example number 1 is says let the function f from set of real number to set of positive real numbers, and another function g from set of real number to set of real number, and those functions are defined by the formula f of x equals to x squared plus 1. That is the definition or the formula for the function f. And the function g is defined by the formula g of x equals to x squared plus 1. The question asked here is which of these functions is onto function. Solution to this problem: let us consider the function f first. The function f, which is from set of real number to set of positive real numbers, and is defined by the formula f of x equals to x squared plus 1. Look at this formula and analyze the end result after substituting different values in the domain. Because of this x square, the square of x, so any number you pick, be it negative or positive, after squaring it, the result will be positive. So adding any positive to 1, the answer will still be positive. Therefore, the codomain of our f, which comprises only positive real numbers, so all those real numbers in the codomain will now have pre-images, because whatever value you pick in the domain, the result will be a positive number. So since all real numbers gives a positive f of x, then the function f is an onto function, because there won't be any element in the codomain without a pre-image in the domain. So let us consider the other function g. The function g, which is from set of real numbers into set of real numbers, and the function g is defined by the same formula g of x equals to x squared plus 1 as the function f. So there also analyzing this formula, any real number you pick in the domain, its image is going to be a positive real number. But the codomain of this g, a set of all real numbers, not only positive. Therefore, there will be some elements in the codomain without pre-image. So g of x is a positive for all real numbers in the domain. It thus implies that all those negative elements of the codomain will not have pre-images. And if some of the elements in the codomain don't have pre-image, then that function is not an onto function. So we can conclude that the function g is not an onto function. And this is the end of this lesson. Let us quickly revise some of the things that you have learned in this lesson. In this lesson, you have learned that some of the types of functions include the constant function, one-to-one function, and an onto function. These are the 3 types of function we have discussed in this lesson. You have learned that also in this lesson, that in a constant function, all the elements in the domain have same image in the codomain. That is, the range consists only one element. This is something that you have learned in this lesson. You have learned also in this lesson that in one-to-one function, different elements in the domain must have different images in the codomain. This is what we learned in this lesson. Finally, you have learned also in this lesson that in an onto function, all the elements in the codomain must have at least one pre-image in the domain. That is, in an onto function, and the range of the function is equals to the codomain of the function. These are some of the things we have learned in this lesson. So thanks you for listening.